Let's get started. First off, wanted to talk about a couple things. I realized sort of after everybody had left yesterday, like one person was still in the room, and it occurred to me that I didn't talk about the microscope practical assignment, but I see that many people went ahead and did it, which is fine. The point of that, it was just 20 multiple choice questions based on some pictures of the kind of things that we captured on the microscope last time. It's, in the greater scheme of things, not a huge part of your grade. It's twice as much as the lab quiz. Not a big thing for your grade overall, but it does sort of start to give you an idea about the practical exam, sort of the kind of questions I ask. What I want to do to begin with actually is to tell you about the practical exam and what's expected of you. Now, our next lab that's when we're scheduled to have the practical exam.
Next Wednesday?
No, our next lab. Next Wednesday, the 25th, the school has switched to following a Monday schedule on the Wednesday to make up for a snow day. So we won't meet again for 2 weeks. What would that be? The March 4th, maybe 3rd. I don't remember what the date is exactly, but that first Wednesday of March, 2 weeks from today. What's scheduled for that day is the practical. And so I want to explain what's going on with the practical for a sec so that you know what's going on. I have some stuff in the syllabus to show you a little bit later on. That's why I was on this page. But the practical folder here, week 6, I haven't updated these numbers here. So this says that week is the 25th through the 3rd, but the school's changed the schedule. So actually, that'll be, yes, I was right, on the 4th, we'll take in the practical. In this folder, you'll find 3 things here. One of them are the cases. Now, the cystic fibrosis case that we looked at is in that document. So I should have shown you that document before, but I want to talk all about what's in here. First off, I just want to give you sort of my impression of practical exams. If you've taken A&P before or some other laboratory science class, you've probably had a practical exam. But the way I do practicals is a little bit different than the way most practicals are handled. The idea of a practical exam is you're being tested on the practical information, the stuff that you studied there in lab. It's based on the idea, say, from your traditional medical school anatomy course type of thing, where the students are dissecting a cadaver and then they're tested on what they know about the anatomy by having the instructor basically stand there at their dissection and pointing at different things and asking them, what's this, what's that, et cetera, et cetera. All right, everybody's here. So, anyways, so that's the idea. They're quizzing you on recognizing structures that they did in the sections. When I took my freshman biology course back in college, Intro to Biology, which is essentially what Biology 102 is here. The laboratory component of that, which is not at all how we have it set up here, was called taxonomy. And what we did is we just dissected various organisms and learned about the relationships between different species and that sort of thing. And the practical exam was kind of along the same lines. We had dissected specimens. Some of the organisms that we ourselves have dissected are the graduate student that's teaching the lab that dissected himself. And pins or pieces of tape or whatever pointing at various things on the sections. We have to name what the parts were. And then on top of that, what taxonomy is understanding about the organization, naming of organisms, genus, and species. So we were asked about, what family and order and those sorts of things that different organisms belong to, that kind of thing. The way that a lot of my colleagues handle their practical exams are kind of based on that same idea. They might do some dissections, but that's actually a fairly small part of what we do in this course. And personally, I don't have any dissections reviewed in AP1, which is really because it's not a great thing to do in AP1. I do a dissection in AP2. So if you're looking for a dissection, there will be a chance to do that in the future, but this doesn't fit in with AP1. So whether they're dissections or not, usually what happens is the room is set up, usually at the 4 tables here. There's over 24 different stations, and they have things like these models or microscopes or specimens like the bones or something like that laid out, and you're being asked about what you see. So I could put a piece of tape on this and ask you, what's the tape indicating, what organ system does it belong to, what body cavity is it in, that sort of thing, whatever the material covers. And the way it works is that you move through the test. The test is all physically set up around the room, and you go from station to station answering questions based on what's in front of you. I don't like that approach to testing exactly for 2 reasons. One of them is actually kind of selfish. It takes a real long time to set those things up, to put everything out all around the room, and et cetera, et cetera. And I've sort of had that approach all along. I've never really set them up that way, and my colleagues are now very envious of me because I don't have to sit around and set up tests like they do. And now we have so many A&P sections that there's sometimes only 15 minutes between classes, and my colleagues are trying to set things up at the last minute. I just walk in and let you go right away. So that's great for me. But that's really the selfish reason. The less selfish reason, the one that really has to do with you, is that that's really not an appropriate way to test you on the material, considering what you're going to be doing with your career in the future. So instead, I've kind of reimagined what a practical exam is, and instead of the practical material that you're being tested on, it's more practical real-world situations and how that relates to what we're studying. So for that, I use these case studies, and that's what it's based on. Now, if you open up this document with the cases, you'll see that there are 4 cases listed. Come on. So case number 1 here, case number 2 just below that, which happens to be the cystic fibrosis case that we talked about earlier. And then there's 3 and 4 down here. Basically, across these 4 cases, we touch on all of the subjects that we cover in the lab here. The first case is really about body cavities. I think we did the first day. A football player injures himself. I'm letting you know a little bit about what's going on in the case here. He has an internal injury. And the way it relates to what we study is you basically have to figure out which body cavity that injury took place in based on what the case describes. The symptomology in the case should point you in the right direction to understand what's going on. Case 2, the cystic fibrosis one, that basically covers the molecules, cells, and tissues. So the stuff that we've covered up to this point so far. And then cases 3 and 4 are both about broken bones. One of them is about a teenager who gets in a motor vehicle accident, and the other one's about a woman with osteoporosis. So just different conditions, different situations where bones are broken. And between the 2, it kind of covers most of the entire skeleton that way, or hits at some of the major parts of it. So that's what the point of the 4 cases is. It kind of goes through all the material, but relates that material to a real world situation, which might be something similar to what you're going to be dealing with in your future career. Now, it happens to be that the cases I use tend to be fairly medical based cases. So if you're going into nursing or something like that, they're rather appropriate. If you're going into surgical tech, they don't quite fit. If you're going into dental hygiene or something like that, I don't have any dental hygiene type cases. I keep meaning to sit down with my dental hygienist to talk about that, but unfortunately, every time I see her, she sticks her fingers in my mouth and I can't talk. So
What?
I go to my dental
this is
hygienist.
Joe.
Yes,
Please.
I do this. No, so yeah, we just haven't found time to talk about it because when I see her, it's to be her patient, and we don't really get time to talk about it so much. Anyways, that's just to say that the cases tend to be more medically oriented than anything else. Now, when we went over the cystic fibrosis case, I explained the idea that I expect you to be able to look at these cases and make sure you understand all the terminology, which includes definitions, jargon, and abbreviations, that you can pull out a list of the symptoms and signs that are described or the functions that are lost, and then relate that to the organ systems that are affected by those particular symptoms. I expect everybody to go in reading through these cases to get that much out of it. And so the test that you're going to take is based on you having that understanding. Now, also in this folder on Blackboard, there's another document here, which is an outline. And all this is just a reminder of the stuff that we've gone over. This isn't some sort of exhaustive list of all of the stuff that the test is over. Rather, just runs through a quick mention of the various things we've done. If you open it up and look at it, you'll actually see that the first 2 pages get us through everything we've done up to this point. Okay? And the rest of it, which is like 5 pages long, is about the skeleton. And what I did with the skeleton, because there just isn't time to go through the entire skeleton in a lot of detail, instead what I did is in the outline, I basically listed all the bones, and I said at least a sentence worth of information about each bone, so you can sort of see where I want you to focus your understanding about the bones. But that's all there. So those are the 2 documents that you have available to help you study. You need to make sure you read through the cases and understand them to the level that I've explained that you should. And the outline kind of paints a picture of all the stuff that we've covered. Now, the way that the test works is there's 2 components to it. Next time we come in, which again is on the 4th, not the 25th, you're going to sit down and take a 50 multiple choice question test on this material. Now, there are 4 cases and 50 multiple choice questions on the test. 4 doesn't divide into 50 perfectly. So it's going to be 12 or 13 questions roughly per case. And in fact, when you come in, the test that you get, I don't know if I have any here. No, I recycled them all. But let's pretend this is it. So I'll hand to you a stapled sheet of papers. There will be a place for you to write your name at the top. And then the first thing you'll see will be case 1. And exactly what's on the page there will be reproduced on the text. You don't have to memorize the case. You'll have it there in front of you when you take the test. And then following that will be the 12 or 13 or whatever questions that go with that case. And then after those questions, it'll say case 2. And it'll have everything that's in case 2 right there on the board in front of you. I mean, right there on the test in front of you. You don't have to memorize any of the information. You just have to be familiar with what it says. And it'll be followed with the questions that relate to that. And the same thing for case 3 and case 4. Now, within that dozen or so questions per case, I like to describe there as being 3 different types of questions. The first type of question I say is about the case. So I'm going to have questions to be sure that you understand what's going on in the case. There'll be questions about maybe the terminology, maybe some question about what the symptoms are, what they mean, or maybe some question about the systems involved. And within that, I'm going to be asking questions that get into the basic information that we've studied in this class. So if it's about cystic fibrosis, the questions might be about what type of tissue is affected in, causing the, this is a horribly worded question, but the coughing that our patient is experiencing is based on a defect in which tissue or which type of tissue or something like that. So what tissue is affected that's causing her to have a cough? Why is she coughing?
Connective?
So, why is she coughing?
Because of an infection in the respiratory tract.
And why is there an infection? Why did those
There's like
pathogens get in there? What?
fluid in there.
Right. Fluid, mucus is building up there. So what tissue is making the fluid that's allowing those infections to?
The epithelium.
Right, so it's an epithelial question. And if it's cough, which system are we talking about?
The respiratory.
Respiratory. So which epithelium would it have to be?
Muscle.
No, that's not an epithelium.
Columnar.
No, I mean, kind of technical.
Oh, is it the lining, the
Yeah, what-
simple columnar,
Not
the
simple.
stratified columnar? Simple. Oh, man.
Okay, you just keep calling them out until you get the
Which
right
one
one.
lines the lines?
Simple cuboidal.
No,
Simple stratified.
sorry,
Simple stratified.
not simple stratified. That actually doesn't make any sense. But
Is it
what you said, yes, pseudo-stratified.
Pseudo-stratified.
That's what lines the respiratory tract. So that's going to be the epithelium that's affected in the disease and causes her presentation of cough. So that kind of question. I did not word that question at all well because I was kind of coming up with it off the top of my head. But that's the sort of thing that I might ask.
But it's multiple choice?
Yes, it is multiple choice. And then the question before
Well,
I
no,
go?
but you mentioned about the bones, that you have a list, listed the bones and wrote a sentence about.
That's in the outline.
Okay, yes, all right, but you want us to like read and know that.
That's so I can give you all that information in one place because we won't have time to do all that today.
Right, okay, but that's
Okay,
for the.
let me keep talking about the
Go
text.
ahead, yes, all right.
Okay, so that's the first type of question about the case and the basic A and P behind the case. The next type of question I like to say is a question that's not about the case, which might sound like I could be asking kind of anything. But really what I mean is each of these cases is about a particular unit that we've studied, or group of units. So again, with the cystic fibrosis case, a question not about the case would be a question about tissues that are not involved in the case. Okay. So generally the tissues that are involved in the case are epithelial tissues that secrete mucus for the most part. But there are plenty of other tissues. I might ask about transitional epithelia in the bladder, which is not at all related to the case. Or I might ask you about connective tissues, that sort of thing. I don't want to completely limit myself and say that all the questions are going to be about the case because I want to have the latitude to ask you about some of the other stuff that we studied in the class. But so there might be a few questions along those lines. I kind of got away from sort of what I want to do in this. Within the dozen or so questions we're talking about, the ones that are about the case, the first type I just described, would probably be about 4 or 5 of those questions out of the dozen. And then the ones that aren't about the case might be 1 to 3 of the questions. And then the third type of question is the more traditional sort of practical question, which means I'll give you something like a model like this, or a microscope slide to look at, or a bone to look at, or bones to tell apart, whatever it might be. And I'll ask you a question there. Now, these are going to be set up on the outside of the room here, so you'll be sitting probably exactly where you are right now, because students never change seats. But you'll be taking the test there, and then you'll get to a question where you have to look at something like this, and you'll get up and you walk over and look at and answer the questions. I try to make those questions about the case also. So it'll be asking me questions about the part of the body where the internal injury is in case 1, or I'll probably ask you questions about, using microscope slides, about the tissues involved in the case, the cystic fibrosis case. Or with 3 and 4, I'll probably ask you questions about the bones that are broken in the case. I try to make them about the case, but sometimes there's just something that I want to ask a question about that lends itself really well to that kind of question, but isn't directly about the case. So of that, I would imagine, let's see, where were we? 4 to 5, 1 to 3, that'd be, the numbers aren't coming out quite right here. There are 2 stations per case, and there should be 4 questions, so 2, but maybe 4 or 5 questions. Yeah, that kind of adds up to a dozen. And I try to make them about the case. Overall, what I would say is probably 8 to 10 of those dozen or so questions are going to be about the case, whether it's directly about the case that you answer there right on the paper, or questions that you'll answer based on what you see in a station. And then 2 to maybe 4 are going to be questions that are outside the scope of the case, but still within the unit that we're talking about. Okay. So I'm not going to ask you some far-flung question that has nothing to do with anything we've studied. It'll all be stuff that's to do with what's going on in class. It's just a matter of what's going on with the case versus what's not. Okay. Now, in studying for this stuff, the outline there is kind of a quick overview. It's not exhaustive. It's just an idea of what we've gone through. But the cases also help you understand what's going on, what to study for. Since most of the questions are going to be based on the cases, be sure that you understand what the cases are talking about first and foremost, as far as the stuff we've talked about. So for the tissues, while there are 20 tissues that we looked at in the microscope, only a handful of them are relevant to the case. Okay? Exactly how many I haven't sat down to really look at. Maybe 4 or 5, not even that many. Tops 4 epithelia that are related to the case. Concentrate on those the best. Make sure you know what they look like under the microscope. Make sure you know what they do, where they're found, and by what they do, I mean their functions, absorption, secretion, that kind of stuff. And you're most prepared for those tissues. Or with the bones, there's 206 bones in the human body, roughly speaking. But only a handful of them are actually mentioned in the case. The first case, case 3, he breaks the tibia and fibula in one leg, his scapula on one side, and a few ribs. So those are the bones that are mentioned. And then in the other case, the woman with osteoporosis, it mentions her wrists and ankles and her lumbar spinal cord, spinal column, and those sorts of things. So it's mentioning certain bones by name, or at least for the wrists and ankles, that region. There are a few bones there that you need to know. That probably comes up to maybe about 20 bones total between the 2 cases. Be sure you know those bones best. You should know all of the bones, you should know all of the tissues, you should know all of the body cavities, those kinds of things, but concentrate on the ones that are mostly that are covered in the cases most. Then you're going to be prepared for most of the questions. Okay? Now, think of it this way. For like case 3, I mentioned the tibia, fibula, scapula, and some ribs. Know those best. You're going to get most of the questions correct, but I'm going to possibly ask a couple of questions that are not about those particular bones within the case. I need to be able to test you beyond just those few bones to be sure that you've studied the skeleton in more detail. But that's basically what you need to do. So that's the in-class portion. There's also an online assignment, which is this third thing right here. So this is an assignment here, which is sort of the last part of the practical. This is made up of questions kind of like the kind of questions you've seen in Part 4 assignments. There are 16 questions. Each case has 4 questions associated with it. So up here, it lays that out. Case 1 is questions 1 through 4. Case 2 is 5 through 8, et cetera, et cetera. Also, in each question, I tried to get it where it says question 1 and question 2. I tried to get it to say case 1, question 1, but I couldn't. So it's actually right there so that you know what case the questions actually apply to. This first one obviously is fill in the blank because it's basically a one-word answer you can put in there. But then most of them are going to be these kind of open-ended questions that you can answer. These are going to go a little bit deeper into the cases. This is going beyond just the terminology, symptoms, and systems approach. In answering these questions, you're going to need to do some research on what's going on in the cases. The questions are going to direct you to, what you need to understand. It's not that I'm going to expect you to look at that case and know everything about whatever condition it's describing, but rather the questions will lead you to research some stuff relative to the case and hopefully get you to understand a little bit more what's going on there. So that's the online portion.
So is that a practice, basically?
No, this is an assignment.
Oh, okay, right, but that's not, okay, never mind. Since then, got it.
So as far as how this works grading wise, the 50 multiple choice question test that you're going to be doing next time you come in, those questions are each worth a point apiece. So it's a 50-point test. The online part, there are 16 questions, 4 for each of the 4 cases, and they're worth 2 points apiece. That adds up to 82 points total. But actually, in the grade book, the test is worth 75 points. So if you happen to score better than 75 points, you get 76 all the way up to 82 points because you get all of those points correct on the test, then those are extra credit points that go into the system. Honestly, that rarely happens. In the 3 A&P 1 classes that I'm teaching this semester, I would expect to see maybe 3 or 4 students total actually break the 75-point barrier. What it really means for most people is it gives you a little bit of leeway. Okay? You can get some questions wrong, and it won't bring your grade down that much. Okay? Because of the way this works, you're going to be doing the in-class portion before you do, or at least I grade the online portion. So you'll find out how you did on that 50 multiple choice question part before you get the full grade for the thing. Just the default setting for a lot of students is they'll see those numbers and translate that directly into a grade. Let's say you get 38 out of those 50 questions correct. Okay? Percentage-wise, that's 76%, and that's a C. But that's not the whole test. That's not what your final grade's going to be. You still have the online portion, and there are 16 2-point questions there. So you can get another 32 points there. If you get 38 points on the in-class portion, you get 32 points more with the online portion. That adds up to 70 points total. Okay? And the test is out of 75. So your grade is 70 out of 75, which is like 92% or something like that. I can't remember exactly the amount, but maybe 92.5%. But that's where the grade is. A lot of times people will take the in-class portion and I'll tell them how they did. And what I say is you got this many points out of 50 correct. And everybody's brain automatically changes that into a percentage, which then automatically becomes a letter grade. That's not how the grading actually works, but that's the way it usually gets processed. Keep in mind that there's also the online portion, and with the extra points that are kind of built into that, that's 76 to 82 points extra. Walking out of here with what might look like a C, 38 out of 50 correct, you're still in striking range of getting an A on the test to get something in the above 92% range. Okay. Now, I always have to qualify a statement like that because students never hear the entire statement. You have to do very well on the online portion. If you have 75% correct on the in-class portion, that doesn't mean you're automatically getting an A. You have to do the work to get the A. What I'm saying is it's not impossible to do that. And I've never actually sat down to do the math across all of my classes, but I have a pretty good feeling that the average score for the online portion is probably about 26 or 27 out of the 32 possible points. And that's not a normal distribution, which means it's not a bell-shaped curve. That doesn't mean most people get that number. That's just the average. Most people probably get a little bit higher than that. I would imagine about half of my students are going to get a 30 or 32 on that. If you put the time into it and really think about it, you can do well on the online portion. Just understand it's not a given. You have to do the work to get that grade. There are some people that really kind of don't get it and their grades are pretty low, and that sort of brings the average for that portion down. Like I said, maybe 26 or 27 total. Where was I going with that? So if you're thinking about how you're going to do in the grade on the thing overall, it's not at all far-fetched to think that what looks like a C can go up to an A. To see a 2-letter grade change based on your performance on the in-class portion. It does take some work. Oh, I know the other thing I was going to say. The online portion, a lot of those are open-ended questions. And what I'm looking for is to see that you understand what the question's getting at and that you're thinking about a reasonable answer for it. They're the same kinds of questions that are on the Part 4 assignments, which I have 6 points to grade with. So with those, I can give you 5 if you don't quite get it or something like that. But when I only have 2 points to work with, the grading scale is a lot looser. Basically, the way it works is if your answer shows me that you thought about what question I'm asking and you did some serious research to figure out what's going on and give me a meaningful answer back, then you get 2 points. If you answer something in the right neighborhood, kind of, but it's just a little off base, so I know that you kind of get what's going on, but you weren't right quite there, then you're going to get 1 of those 2 points. And then if you're just completely off base, you won't get points. Right? So that's sort of the grading scale for a 2-point question, whereas when it's a Part 4 assignment where I got 6 points, I can be a little bit more exacting about how many points you earned here and there. So 2 people can answer one of those questions completely differently, and they both might get 2 points because they've satisfied my requirement to show that you've thought about the question and you've done some meaningful research to get to a relatively correct answer. Generally, what I have going for most of those, in my mind, there are a few keywords that I'm looking for. And when I see those keywords, I know that you've found out what you're looking for. I do read the whole answer because one thing that's very important is I want you to be sure to limit your answer to what the question is asking. So if you write a half-page answer and I see 3 keywords that I'm looking for, that doesn't automatically mean that you get 2 points. If you wrote all of that because you just sort of threw up everything you can imagine onto the page, so to speak, you're not going to get full credit because that's not thinking about the question and answering it thoughtfully. So I do read through them and consider how you've answered it. But generally speaking, there's a few key points that I expect to show up in most every answer, and that's what I'm looking for. So that's basically how the practical works. Any questions on that? Yes.
Do you want the online portion to be done before we commit to it?
The due date for that is before the next class meeting after that, which is actually quite a ways in the future.
So like 3 weeks.
Actually, I can't remember if I changed the dates, but really this week here, as far as the dates are concerned, should be this week here. The following week, I'm going to Chicago for my conference, and then the following week is spring break. And so your next class meeting will be March 25th. So yeah, it needs to be done by the 25th. Yeah. Question?
I just doing the, I can't remember what it's called, the lab portion that you had to identify the tissues.
The microscope practical?
Yeah. Doing that, it was really hard for me to see them, the images, and like make a distinction of like what type they were. So I mean, like for some, it's easy, but like some to me just look like a bunch of splatter, so it's hard for me. Is there any way you can just maybe like go through them and just say like, this is something to look for to see?
Honestly, no. And by that, I mean not in class. We just don't have time to go through that. But if you want to sit down at some point, and talk about that one-on-one, I'd be happy to do that. But there's just not time in class for me to go through all of that. I provided you with the captured images that you all took during class, and so you should be able to look at two pictures side by side.
I'm just like looking at them and I was trying to use them, but they look really similar to me. Like it was hard for me to, like for obviously like a simple cuboidal, like that's not hard to recognize, but some of them are very.
Yeah, so if you'd like, we can sit down one-on-one and spend some time. It's just in the reality of the time we have in class, I really can't do that overall. So I set it up so that you have sort of a reference material to look at and you can compare that to what you have.
How do we access the pictures that we took?
In the tissues folder, there's a link that says
Okay.
microscope capture or something like that, and it'll take you to it.
Do we have only one attempt or we have a second chance?
Oh, yeah, so for the online portion of practical, you have one attempt, like a part 4 assignment. Anything that I have to manually grade, I can't give you multiple attempts because that would mean I'd have to grade things over and over again. There's no timer or anything like that, so you can spend some time thinking about it and crafting your answer. And you're gonna have plenty of time to do that
And
because
both in class and online?
the in-class, you come in and take the test.
Yeah.
It's a paper test.
Only one time?
Yeah.
Okay.
You can't do it more than one time because you only have one day to do it.
No,
I'm not gonna sit there and hand out multiple copies and you get to do it over and over again.
Not even like if we can like fail or something? Just say-
You're welcome to fail it if you'd like to.
No, I don't wanna fail it. I'm just saying maybe people will fail and they wanna retake it.
No, that's not the way it works.
No.
You have to go in and take it. Now, the microscope practical kind of gives you a clue as to the kind of questions I'm gonna ask. So that's the sort of thing you should expect, but as far as the material you have to study, you have to prepare for that test. And I don't tend to see people really bomb on the test. People think they really bombed on the test, but in the end, it doesn't really affect the grade that much. A single practical probably amounts to, I don't know, 5 to 7% of your overall grade. So as long as you're strong and everything else, if you have troubles with this, it's not going to really affect your overall grade.
How many of these do we have?
How many of these? 2. So we'll do this one in our next class meeting, and then we have another one at the end of the semester. So this one's basically over the first half of the semester, which is up through the skeleton, and then the other one will be on muscles and nervous system.
And those are the only in-class.
Yeah, those are the only things that you do in class. Everything else is online.
So the second one is not cumulative?
Sorry?
The second one is not cumulative?
The second in class, the second practical is about the second half of the semester's lab material. The cumulative thing is an online assignment. You have a cumulative final at the end of the semester. Any other questions? Okay. So if you are thinking about this and you come upon other questions later on when you're studying or something like that, feel free to contact me. But that's basically what to expect. And again, the school has changed the calendar around a little bit. Next Wednesday follows a Monday schedule to make up for a snow day. So while I just didn't change it here, this says the 25th, but actually it'll be the 4th. And that's a perfect segue to go over to the syllabus page, which is what I want to point out. And all of that, those changes are reflected here. So week 5, what we're in right now, February 18th, integumentary and skeletal systems. The 25th class is canceled because we follow a Monday schedule there. And the 6th, which is, week 6, which is March 4th, that's when you have your practical. Okay. And then the week after that, I'm gone for the conference. The week after that is mid-semester break. And then when we're back on the 25th, that's when we're going to start up with joints, movement, and muscles and nervous system stuff. So it's all laid out there. If you look at the weekly schedule, the weekly folders, the dates there, I actually haven't updated. But this is where it absolutely is laid out time-wise. Okay. Now that's all we're doing that week. We're not going to take that test and then spend the rest of the day doing something else. It's just going to be the practical. So you won't be here the whole time. The test is designed to be completed, the in-class portion of the test is designed to be completed in about an hour. You will have an hour and 50 minutes to work on it if you need to. That's how long a traditional lab period is. So for my lecture lab style classes, that's the whole lab period. So I give students that much time. For my extended labs, hybrid classes, I still give you that hour and 50 minutes, and that's as long as people be. I've rarely had anybody stay longer than an hour, maybe an hour and a half. In my whole career, I've probably had to tell 6 people total that, okay, time's up, time to leave. Because really, it's not designed to take that long. You have an hour and 50 minutes if you need it, but I doubt many people will. And so if you want to make plans for that Wednesday, again, the 4th, feel free to start making plans starting at 3:30. You definitely will not be here past 3:30. It's very likely that you'll be out of here by 2:30, but you don't want to make plans at 2:30 because if you need it, you have more time to work on stuff. So yeah, after today, there's not a whole lot of time that we're going to spend together over the next month. Just about an hour and a half on the 4th, and then I'll see you at the end of the month again. It'll be so sad, I know. But, yeah.
Are we, that whole month, we're not gonna see you do stuff to do online assignments or no?
No, all of the assignments are based on classes. So you'll have assignments for the skin and skeleton stuff, which I might have actually set those due dates up for the 24th also, since we don't have anything else in there. You can do all those. I do want to mention that this week we are technically covering 2 chapters. So you have 2 sets of part 1, 2, 3, and 4 assignments. But because of all of the time off and the lab practical and all that, you'll have plenty of time to work on. And they should all be set to be due on the 24th. If they're not, let me know.
24th of February or
March. Because we don't really have another class until we get back from break. So there's no point in having them due sooner, because it's not like you have to have those done before, you can do another chapter's worth of material. We're not going to have another chapter until March 24th.
What about the learning plan? Because we do them
Oh,
before we come.
Yeah, I'll talk about that in a second. Question?
Yeah, so how many chapters is the test on? Because are those chapters that are due on the 24th of March and be on exams?
You mean the practical?
Yeah.
Well, the practical is about lab material.
Yes.
The chapters are technically lecture material. It wouldn't hurt you to look ahead at that stuff and maybe get started on it, but it's not exactly the same material. So we don't really do any skin stuff in lab. I don't really bother with the skin a whole lot in this class at all. But as far as the laboratory component of the skin, it's really about the tissues that are part of the skin we looked at last week. And then for the skeleton in lab, we're considering what bones are, what they're named, where they're located. The lecture component is more about how bones grow and heal and that sort of thing, which aren't quite.
I don't see so much of a distinction because we don't have different days. You know what I mean?
But there is a distinction.
Okay.
It's partly in how the material is presented. So this is all based on the case studies. If you understand the case studies, then and what's needed to understand those, then you're fine.
Okay.
It's not necessarily that you have to do the chapter assignments to be prepared for. But I was reminded here, the Learning Pod thing, I have a couple of things to say. One, yes, you will have Learning Pods on the Joints chapter, which will be due on the 24th, which is when we do that, again, March 24th. So yeah, you don't have any Learning Pod assignments that are due between now and the 24th. We aren't doing any new chapters over this time, especially holidays and all that. But you probably received an email from Learning Pod saying that they're shutting down. In the end, that doesn't really matter too much. What I'm going to do, or what I'm in the process of doing as we speak, so to speak, is I'm converting those Learning Pod assignments into Blackboard assignments. So you will still have those assignments to complete. You just won't be doing them through the Learning Pod website, because the Learning Pod website won't exist anymore. Well, right now, when you go to a Learning Pod assignment, like, okay, so like in a weekly folder, to go to the assignment, you click on the link down here and it takes you to Learning Pod page with that pod on it. This will no longer be there. It'll say some other lame description about what the assignment is. And so instead you'll click on the title of the assignment and it'll take you into a Blackboard-based assignment, just like all the stuff that you normally do. What I have to figure out, I just got to talk to the Learning Pod guy, the Blackboard guy here on campus, because I'm not quite sure how to do it, to set it up so that you get credit for completing it regardless of how many questions you get correct. They'll work as far as you're concerned exactly the same. It just you'll be staying in Blackboard to complete the assignment rather than going on to the Learning Pod assignment page. What I'm going to do is basically I'm going to start at the far end, the last Learning Pod of the semester, and replace those as I go back, which probably won't really make any difference for you guys. But in doing that, if I get to a Learning Pod that somebody's already completed, I'll replace that with that assignment with a Blackboard one. And then for the people that have already done that Learning Pod, I'll go ahead and put in the 2 points that they've already earned for it. I expect that I'm going to spend most of my time over spring break doing this. So I would anticipate that actually when you come back after spring break, it'll be set up this way. If you happen to, over spring break, go ahead and get the joint chapter Learning Pods out of the way using the Learning Pod assignment where I've switched it over, that's fine. I'll get information that you completed it, and I'll give you the 2 points there. It's just, if you're doing those Learning Pods like the night before they're due, or the night that they're due at the last minute, you'll probably be doing them on Blackboard because I've already, hopefully, have gone through and converted everything like that. So as far as you're concerned, the assignments aren't really going to change. It's just a change of where the assignments set up that you're going to be looking at. So I think that's everything I want to talk about. Any other questions?
Are they gonna be timed on Blackboard?
Oh, that's a good question. Maybe. But again, since they're multiple choice questions, I'll think about it. Because they're not timed on Learning Pod. So, other Blackboard assignments with multiple choice questions are timed. So it's a philosophical issue on my part. I'll have to decide what to do. Anyways, so that'll all change kind of behind the scenes. You don't have to worry about it. So, now, we do actually need to do some content today. We actually have quite a bit to deal with. And partly in that, what we have to deal with is something I don't want to spend a whole lot of time on. The skin chapter in any of these books is never terribly interesting. I don't really care to spend a whole lot of time on it. Because really a lot of what's going on in the skin is just an extension of what we cover in the tissues chapter, just specific types of tissues. What's best for the skin is kind of making the transition from these foundational things, the chemistry, cellular, and tissue levels of organization, up to an actual organ system. And what I really want you to pay attention to and think about in the skin is what tissues are there and what role they play. When we're moving up to the organ level of organization, we're going to see all 4 types of tissues represented, and that's true in the skin. Now, the skin is mostly made up of epithelial and connective tissues, but it does have a little bit of muscular tissue and some nervous tissue in it also. So think about what those tissues do in the different functions they perform for the skin. So I just want to point out a few different things. This is just your average overall picture of the skin. The epithelial portion is up here at the top, which is the epidermis. It is a stratified squamous epithelium. And then below that, the rest of what we have here is the dermis, until we get down to where there's mostly this fatty tissue. So all of the tissue between the epidermis and this adipose tissue, that's the dermis. It is mostly dense, irregular connective tissue. There's a little bit of areolar connective tissue right next to the epidermis up here, but the majority of the dermis is dense, irregular. The adipose tissue that we see down here belongs to what's called the hypodermis, or the subcutaneous fat. It's really not a layer of the skin. It's what's below the skin. It's the connective tissue that connects the skin to deeper structures. But it's usually described in the skin chapter because it does have some functions relative to the skin. One of the big points of the skin is it helps in temperature regulation. And partly how it does that is by controlling blood flow. There are smooth muscles in the wall of blood vessels, and when you're cold, those smooth muscles contract so that blood flow decreases in the skin, and it stays down in the hypodermic and lower levels, which are insulated by all that adipose tissue. And there's a lot of blood vessels in that layer helping with that. When we're warm, the smooth muscle relaxes so that the blood vessels dilate and a lot more blood flows into the skin, where we can then radiate the heat off. And also there are sweat glands in the dermis which will filter water out of the blood to create sweat, and that sweat is excreted onto the surface of the skin, which will then help radiate that heat off through evaporation. And the book goes in to describe that process a little bit more. But so I talked a little bit about the smooth muscle in the blood vessels here playing a role in temperature regulation. There's also smooth muscle connected to hair follicles, which are kind of related to temperature regulation. In humans, they don't really do anything, but in other organisms that have fur, hair follicles are tied to temperature regulation. We still have, the hair stand up on our skin when we get a chill or something like that, but it doesn't really help us stay warm or anything. But with a dog or something like that, when its hair stands up on end, it creates a little barrier that can trap warm air next to the skin to help them stay warm. For humans, there's just not enough hair to do that with, but it still behaves that way. And that's more of the muscle tissue here. The nervous tissue that we see down here, there are a bunch of nerve endings in the dermis of the skin, which are there to interact with the environment around us so that we sense touch and temperature and pain and vibration and all those various things that we consider touch under the umbrella of our sense of touch. All of those are in the skin there too. That's the nervous tissue. So those are the four major types of tissue. Epithelia in the epidermis, to connective tissue in the dermis, and then also in the dermis we have blood vessels, which contain muscles, and the muscles attached to hair follicles, as well as nervous tissue for the sense of touch. So they're all there. There's a bit more going on. Hair follicles are epithelial in structure. Their cell types are very similar to what's in the epidermis. Blood vessels aren't just muscle. They're going to have their own epithelial and connective tissue layers to them also. So there's all sorts of stuff in there. Okay. And then we have glands, whether it's oil glands attached to the hair follicles here, sweat glands or whatever. Glands are a type of epithelial tissue. So that's a quick run through of the skin, and the book certainly describes it plenty well. In the epidermis, the cells are organized into different layers. At the base, there are cells that have specific functions. There are cells that make pigment called melanocytes. There are cells that are related to the sense of touch, which are these blue things here. And then the other cells are dividing and making new cells for the skin. As cells divide here at the base of the skin, base of the epidermis, the new cells push up and push older and older cells up to higher and higher layers. Eventually, when we get to the top of the picture here, the apical part of this epidermis, that's where the cells finally kind of slough off and we get rid of them. The thickness of the epidermis is actually thicker than the tissues need to, the cells need to survive. The distance from, say, right here down to the blood vessels in the dermis is just at the limit of how cells can stay alive to get nutrients and clear away waste products. Beyond this level here, the top two layers of the epidermis, those are all dead cells, which is actually a good thing because they help protect the living cells underneath as well as the other tissues deeper to the skin. And then eventually they come off because they sort of flake off. What holds those dead cells in place is a special kind of protein called keratin. And those cells, as well as all of the other cells in these layers, are called keratinocytes, okay? Because they contain keratin. You could pronounce that keratinocyte if you prefer. But that's what all of these cells are. They're born down here at the base, and over their lifetime, they work their way up to the top until they finally come off as dead cells up here. The other cell types, melanocytes and Merkel cells, are not keratinocytes. They're different types of cells. But all of the things that are colored yellow in this picture are the same kind of cells, and they begin life down at the bottom, and they migrate up as newer and newer cells kind of push up below them. So the book goes and talks about the different layers. The dermis I kind of already talked about. It's mostly dense irregular connective tissue, which is what we have down here at the bottom. That's labeled the reticular layer. And then at the top, this bracket is showing us where areolar connective tissue is. That's where the blood vessels are that supply the epidermis there. And that's explained here. And then they go on to talk about the hypodermis a little bit. It's not really a layer of the skin. It's right below the skin, but it's important to some of the functions of the skin there. I talk a little bit about pigmentation, which is about melanocytes, and moles are just where pigmentation's kind of gotten carried away, and some other things here. The accessory structures of the skin, that's about hair follicles and nails, and then also glands. I just want to say something about glands. In the book, they talk about the sweat glands, which are called sudoriferous glands. There are two types, eccrine glands and apocrine glands. And the book describes the difference between those. I wish I had time. I have some interesting stories to tell about sweat glands, but I don't really want to go into that. And then they talk about sebaceous glands, which are oil glands. Those are not the only glands that are found in the skin. So besides the sudoriferous glands, of which there are two types, there are sebaceous glands, which secrete oil. And then there are ceruminous glands. And that's how you spell it, which secrete wax. And cerumen, with an E instead of an I, by itself, that means wax. And then there are mammary glands, which you've probably heard of before, and they secrete milk. Okay. Sebaceous glands, as the book describes them, they're kind of their own thing. They work a little bit differently. But really, the ceruminous and mammary glands are just variations on sweat glands. Okay. Yes, there are a couple of different types of sweat glands, but as far as the major types of glands we have, this runs through them. And wax glands are variations that secrete a waxy substance, which is lipid-rich. And then milk glands are a variation on sweat glands that secrete milk sugar, lactose, and milk proteins, along with the water that's in there. So they're kind of similar structures there, or functionally. But actually, back in the tissues section, they talk a little bit about the structure of different types of glands. And again, the skin chapter is really kind of an extension of the tissues material that we talked about last week. And then there's a section on functions of the skin. And in reading through that section, which I'm not going to even bother opening up and going through it, just consider how the 4 different types of tissue play a role in each of those functions. That's an important part of really understanding what the skin's about. And getting from the foundational stuff, those levels of organization chapters, into the organ systems. And if you start thinking about how individual tissues play a role in the functions of organs, then it'll kind of help you out. Okay. And you can look at the diseases and disorders. Really, skin diseases kind of creep me out, so I'm not going to even go there. But then the rest of this section, or not the rest of the section, but the next few chapters here, we have a chapter on bone tissue, which is about the tissue and about largely how bones grow. And then that's followed by 2 chapters, one called the axial skeleton and one called the appendicular skeleton, which is about the bones that make up the skeleton. Okay. And for today, we're actually kind of going all the way up through that stuff. You had learning pods, one on the epidermis, one on the dermis, and then one on the chapter on the skin. And then you had one on the chapter on the bones, and one on the chapter on the axial skeleton, and one on the chapter on the appendicular skeleton. Now, the first time I started using learning pods, the week that I was preparing learning pods for the bone chapters, learning pod was down, and the chapter ones were already existed, but I couldn't write new pods. And so since there were 3 chapters worth of learning pods there, I didn't write additional pods to go with the bone stuff. So that's why you had a couple of skin pods and the skin chapter pod, and then you just had these 3 more pods that go with that, one over each of those chapters. Now, the part 1, 2, and 3, 4 assignments on the skeleton, on the bones, are really based on this chapter that's the bone tissue stuff. You don't have chapter assignments on the axial and appendicular skeleton. Rather, this is the lab material for this week. And in the second half today, we're going to basically be getting to know the skeleton a little bit better. Now, in the bone tissue chapter, it really kind of highlights the idea of how bones grow. The first couple of sections here are just talking about what bones are and how we classify them, which isn't terribly important. Within the classification picture here, which you can look at, the point here is just to show you that this is a long bone. This happens to be the thigh bone, the femur. And long bones are a little bit different than the other ones in that they're organized into a shaft, a central shaft called the diaphysis, with a head at either end, which are called epiphyses. So this bone that's been sawn in half is the tibia, which is your shin bone. And at one end of what we have here, where it kind of flares out at the bottom, this is one of the heads. This is one of the epiphyses. And then we see sawn in half the shaft or the diaphysis bone. And then my colleague who prepared this cut the other epiphysis off the top, but there'd be another one there. All of the other bone types, and their shapes aren't terribly important, are just a little less organized than that. The shaft of a long bone has a very thick, compact bone wall, giving it a lot of strength. The epiphyses of a long bone have mostly spongy bone in the middle with a little bit of compact bone shell on the outside. You really kind of see that in that sawn open bone. All of the other bones essentially have that same kind of structure, like an epiphysis of a long bone, which is a very thin shell of compact bone on the outside, giving it a smooth outer surface. But then the central part is all spongy bone. Now, the point of spongy bone here is partly to be lighter in weight. If your bones are just solid, compact bone, it'd be really hard to break your bones, but it'd also be really hard to walk around because you'd be so much more massive than you are. Now, actually, if we're going to make that kind of speculation, if you had solid, compact bones, you'd also have an immense muscular system to be able to move all of those. But that's not the way it works. So inside the epiphyses of a long bone or inside any of the other types of bones, it's all spongy bone, making it a little bit lighter. The different shapes aren't terribly important. We have flat bones, which aren't really flat. They have usually a bit of a curve to them. We have short bones, which aren't short versions of long bones. They're just small, usually kind of cube-shaped bones. Typically, the wrists and the ankles are the place where we describe those. And then we have irregular bones, which are basically bones that don't fit into those other three groups, which is most everything else. They also mention another type of bone called a sesamoid bone, but the only sesamoid bone that all humans have in common are the kneecaps. Okay. The thing about sesamoid bones is that they develop differently from other bones. And some people have sesamoid bones other places in their body, but they're kind of unique bones, depending on how it has to do with how they develop. So really the point of this is just to set up, this is what a long bone looks like, because that's sort of the example bone we're always going to be talking about. And what we say about long bones applies to all the other bones, mostly in terms of what the epiphyses are like, because that's what all the other bones are like. Okay. The main part of this chapter that I want you to consider is, one, the basic structure of bones, which I kind of talked about. Here's a long bone. The central portion, the shaft of it, is hollow with a thick, compact bone wall. And then the heads, the epiphyses at either end, have a very thin, compact bone shell on the outside with spongy bone in the middle. You can see this little line right across the center of, or right across the edge of the epiphysis. This is where the bone grew longer. Okay? In an adult bone, that's going to be bone. But in a child or an adolescent, that's actually cartilage, which can then grow and the kid can get taller. When you're an adult, that cartilage calcifies into actual bone, but you can see a little hint of where that used to be. Okay? There's a bracket around that area. It's called the metaphysis, which is not a terribly common term, but it's just the transition from the shaft of the bone to the head of the bone, okay, where it tapers out to be wider for the head. And also that's where the growth plate was located. It goes on to show some of the structural organization of the tissues more down at the cellular level. And what's important about bone is it has all of this extracellular space, which is the bone matrix, the calcified stuff. And in fact, what I'm holding for you right here, this is all bone matrix. This is a dead bone. And the cells and blood vessels and nerves that used to be part of this bone are no longer there. They've all degenerated away. And what's left over is just the hard calcium phosphate crystal structure of the bone matrix, which we see there. And so really a lot of what makes up the bone is the extracellular structure. And they're just some cells worked in between there, which they kind of highlight in this picture. And there's another picture in a little bit that shows some of that. There's a special picture here just showing you what a flat bone looks like, which is really just like an epiphysis of a long bone squeezed flat. There's a thin compact shell on the top and the bottom of the picture, and the middle is filled with spongy bone. There's a special kind of word for that spongy bone that's in parentheses down here, which don't worry about. It's, I'm actually not sure what language it comes from, but you don't tend to see that word too often because it's just a special word for the spongy bone in a flat bone. What really distinguishes bones from each other are the bone markings, the bumps that we see on them. And what we're going to be doing the second half today is really kind of getting to know about that aspect of the bones. So actually, let me grab the real bone. So you look at a bone and it has bumps sticking off of it. And those are bone markings. Largely, bone markings are places where muscles attach to move the bones, or there are special shapes in the bones so that they can interact with other bones at joints, or there might be a ligament attached. So I grabbed two bones here. One of them is the femur, which is your thigh bone, and the other one's the humerus, which is the upper arm bone. Now, the arms and legs are kind of analogous structures. You have one bone in the top part, two bones in the bottom, and then the appendage, or hand or the foot, is attached through a series of short bones. And then in the hand and the foot, you have 5 digits, which have a major bone in the palm or the arch of your foot, and then smaller bones coming out for each digit. There's 2 in the first digit of either hand or foot, and then there's 3 in each of the other 4 digits. Okay. Some people actually only have 2 in their pinky toe because it's such a small bone. But they're basically laid out the same way, arms and legs. So these 2 bones are analogous. They're the upper limb bones for the leg and the arm. But what makes them actually different is how they've shaped themselves to play their particular roles. Now, I don't have children, and I don't know if my wife would really appreciate if we did this kind of thing if we had a newborn. But I'd really like to take a newborn and do all sorts of measurements. Because I would bet that in a newborn, the upper limb for the arm or the leg are pretty similar. Because what makes the thigh bone, the femur, grow so much larger is the fact that it has to deal with the body weight bearing down on it. Okay, so since a newborn obviously isn't walking, they probably haven't put any stress on the bone that way. There's a curve to the femur, and that curve has a little bit to do with how it distributes weight. And so it develops that curve specifically to do the job it needs to do. The humerus, on the other hand, doesn't have the same kind of curve to it because it's not going to do that same kind of thing. And it doesn't get as long because it doesn't have to grow to support a lot of body weight. Now, there are similarities between these bones, both of them at the top of the bone, or the proximal epiphysis, closest to the body. There's a very rounded head because both of them make the same kind of joints. Your hip joint and your shoulder joint, both of them are ball and socket joints, which we'll talk about when we get to the joints chapter more. But there's a ball shape to the head of the bone, okay, in both cases, so that they can kind of glide within that bone, within that joint in all sorts of different directions. They both have the same kind of structure to them. And then at the other end, they both have similar structures where they make their elbow or knee joint. Both of those joints basically bend like a hinge. Okay? So the bone is kind of scrolled just like a hinge would be. So those hinges there sticking out on the door to the side are very much like the the scroll work here on this bone as it kind of curls around. And the elbow joint moves around that bone that's sticking out like that. The knee's the same kind of thing. It kind of curls around here, which is going to go with how the knee joint bends. They're different sizes and different shapes because the joints aren't exactly the same, but they're very similar in the way that that particular joint bends. And so we can see those kind of things, those kind of markings that really stick out. Or that's kind of a pun, I suppose, that really kind of illustrate the different aspects of the bone. In this table here, it kind of runs through a number of different names for types of markings, and their general name, and some examples of some that you might find. One I want to point out, because it's on the bone I'm talking about here, the word tuberosity. In the book here, they define it as a rough surface. Other sources will define it as a small to medium bump. But it's this thing right here. And rough surface is really good description of what we see here in the humerus. Now, it's called a deltoid tuberosity, this one that I've highlighted, because it's named for the muscle that attaches to it. So this bone fits in the arm like this. When I lift my arm out like this, the deltoid muscle, which is this muscle that goes over the shoulder, attaches to the deltoid tuberosity and pulls on the arm so that it raises up like that. At that point, because there's tension where the muscle actually attaches to the bone, it makes the bone grow a little bit thicker right there. And that is what causes a lot of the bone markings to grow. And they give some examples of bone markings here. I just want to point out this picture, you can look at it. Within bone tissue, there are 4 major types of cells. There's an osteogenic cell. Osteogenic cell in this picture here. Osteoblasts and osteocytes. I use those 3 in that particular order because they kind of represent a progression. Osteogenic cells are the cells that originally make the bone, and they mature into osteoblasts, which help the bone grow, and they finally mature into osteocytes, which are found within mature, fully grown bone. And then the 4th type over here off to the side is called an osteoclast, which is very similar to the name osteoblast. They're very different cells, but they kind of play 2 sides of the same coin. Osteoblasts build bone matrix, and osteoclasts take it apart. There's always this balance of storing calcium in your bones and removing that calcium from your bones. And those are the cells that play a part in that. And this table here just lists those 4 types of cells. Little discussion of the difference in compact and spongy bone and sort of what they look like under the microscope. Again, going back a little bit to what was in the tissues chapter. A little box on aging. A mention of blood and nerves that get into bones, because bones are organs within the skeleton as an organ system. They're mostly made up of bone tissue, but they have other tissues in them. And so there's blood vessels and nerves and that sort of thing going into it because they're living organs. The next section here gets into how bones grow. And there's sort of 2 ways that bones grow. Well, actually, there's several ways that bones grow, but the majority of your bones grow through one of 2 means. There's intramembranous ossification and endochondral ossification. Now, ossification is just the Latin word that means bone growth. Intramembranous is talking about bones that grow directly from mesenchyme in the embryo, or in the fetus. And then endochondral growth are bones that grow from cartilage, which is what chondro means. In your skeleton, in the fetal skeleton, most of the bones in the fetus are actually cartilage. And then they end up calcifying into bone tissue through this process of endochondral growth. The exceptions to that, the bones that grow through intramembranous growth, are the bones of the skull and the clavicles, which are your collarbones. I've always thought that the reason why those bones are different from all the rest, and I'm not positive about this, but I think it's a pretty good guess, is those particular bones are the ones that make childbirth hardest. So if you've had a child, you're probably aware of this, that the head and the shoulders are the hardest thing to give birth to. And so those bones growing through intramembranous growth are still quite soft at the time of birth. They're not fully calcified. So it's very easy for those structures to squeeze through the birth canal. You might be familiar with a newborn has a soft spot on their skull because their skull hasn't fully calcified. That's what we're talking about. If a woman spends a long time in labor and the baby's head is sort of stuck in the birth canal for a long time, the head will reform into, kind of this cone head looking shape. But since the skull is still soft at that point, it's not too hard for it to be reformed back into its normal shape. I actually have some friends that, I don't know if exactly that's why it happened, but their youngest had to wear a helmet for a while when he was very young to help shape the head the way it was supposed to be. And unfortunately for the kid, it was, during the summer he had to wear it, so it had to be the most uncomfortable thing. And of course, we're talking about a toddler, or not even a toddler, a newborn. So all he could do was cry like crazy because having that thing in his head wasn't very comfortable. But once it came off, he had a very naturally shaped head, and it was perfect. So we're very happy for that. Anyways, that's the main ways that bones grow. Okay, and you can read how they progress in more detail in the book. In the endochondral ossification picture, they're showing how a long bone grows. For all other bones, the way they grow, aside from the ones that are intramembranous growth, is essentially what happens in the epiphysis of a long bone. Okay, so long bones kind of grow in two stages. The shaft, or the diaphysis, grows first from a primary ossification center, and then the two epiphyses at either end grow second, a little later, with their own secondary ossification centers, which is what this picture is kind of laying out. For all other bones, short bones, flat bones besides the one in the skull, ones in the skull, irregular bones, those sorts of things, they all grow just like there's one ossification center, like in the epiphysis in this picture, and then it grows out from there. But all of those start out as cartilage, and then they calcify into bone through a process like this. Then it talks a little bit about how bones grow in length, which happens at the growth plate. And this is a pretty decent picture. It's two pictures of a femur, and it's longer because growth has been happening at the growth plate at either end. And so the diaphysis kind of gets longer and pushes the heads out, and it gets to be a longer bone. Bones grow in diameter through a process that isn't exactly explained here so well. So what I've done to kind of supplement what the book says here is on Blackboard in the video content area, there's a video that I've posted. It's just a very short little video. Come on. You got to scroll down to get to the point where we're at bone. So that's tissues, skin, skeletal system. So this is an overview of the skeletal system as a whole, if you'd like to watch that video. But this video right here highlights what's called appositional growth, which, it's not in the picture there. Let me write that word out. So appositional growth means basically growing at the edges, okay, or against the side of the bone. And this video here basically shows that. So you can watch this. It's 45 seconds long, and it kind of highlights how that goes. The picture here actually is very obviously from an old textbook that I used to use, but they posted the video on YouTube so we can see it. But it's a pretty good explanation of how a bone grows wider in general. Now, for the most part, this happens where there's stresses applied to the bones, like a muscle attachment point or where it makes a joint or something like that. And it's largely how we get bone markings like this. So like on the femur, there's this huge chunk of bone right here. This is called the greater trochanter. And all it is it's where there's this major muscle attaching to the bone that helps us maintain our posture. So there's always some stress put on the bone right there. And so the bone had to grow thick, very thick, to accommodate all the stress that's put on it by the tension of the muscle pulling on it. Okay. So it grew really thick. Now, it's not always growing for your entire life. Once it gets thick enough to handle the stress of everyday use, it's fine. But if you start applying more stress to it, so like with the deltoid tuberosity, okay, this pump right here, if you start going to the gym and working out and trying to build up the deltoid muscle, the deltoid tuberosity is also going to get a little bit thicker. But that's going to be microscopically thicker as opposed to the very noticeable change in the muscle mass when you go work out or something like that. But those processes actually take place through this appositional growth, which is kind of highlighted here. So, I think that's all that's there. Yeah. It does go on kind of related to bone growth. There's a section in here about fracture repair and exercise. So kind of what I just said there, when you're working out your deltoids, you're going to cause bone growth a little bit. So that's kind of hinted at there, but more importantly, what that's getting at is how nutrition fits into bone health. And then finally, calcium homeostasis. The bones are where we store calcium in our body. And we have a homeostatic mechanism regulating blood calcium levels and hormones that regulate that. And that section there highlights it. The thyroid gland, which is right here, releases a hormone called calcitonin, which tells bones to store more calcium. And then you can't see it in this figure, but on the posterior side of the thyroid gland are these things called parathyroid glands, which secrete their own hormone called parathyroid hormone, and it secretes, it does the opposite of calcitonin. So in that section sort of describes how we balance that homeostatic mechanism through hormones in the bones. So I just want to run through and kind of highlight the things I want you to pay attention to. There's really not time to go into it in a lot of depth. But a lot of this information you can find probably YouTube videos and stuff like that. I pointed to a couple that I've actually embedded into the Blackboard site. But if you want to look a little bit further afield, the one that I have in there, it's by an outfit, or it's called a Crash Course. And I really like those videos. I just like the guy that does them. If you watch any stuff on YouTube, there's something called SciShow, if you've ever seen that. And he's the guy that does that. He's got a nice little sense of humor. Also, he and his brother, he's a scientist and his brother's a historian. And they have sort of, they both do Crash Course. So if you look up Crash Course, you'll find half of them are about science and half of them are about history. But also they have this sort of back and forth vlog, I guess you call it, where 1 week, one brother talks about something, and the next week the other brother kind of responds to that. It's stuff I've seen on YouTube. But that's the, back here, this skeletal system one here. This is a kind of good overview of the whole system if you want to. And there are other videos on YouTube that you can look up that might give you a bit more information. So, Um,